Welcome back to the mountain bike build series. You just saw me prep this seat tube and head tube, but now we got this long boy, this real big down tube, and I need to miter this to fit into the frame here. Let's get into it. So every tube you would like to be perfectly straight as an arrow, and they're not. So you know, they're theoretically kind of straight, but they're not in practice. And if you have a flat surface like this, you can roll the tube, and if you get low, you can look at the little gap, the little sliver of light underneath the tube, and you'll be able to see where the high point is. I don't know if you can see that on camera, but you know what I mean. Just look for the little sliver of light. And here I have this mark that I put on top. This here, that's the top of the tube when I see the most light underneath the bottom of it, right? So you roll it until you find the, you know, you're trying to find the hump, because the idea is when you're making a frame, if it's got like a real squiggle in the tube, and it's, you would like that to be in plane with the frame. You're riding the bike, and if the top tube or the down tube or one of these tubes, if they bow a little bit up or a little bit forward or backward, that's not really a big deal. If it bows off to the side, still probably not that big of a deal, but that's less what you want, you know, like especially when we get the frame welded together. I'm going to strap it on this table, and I'm going to be doing alignment checks with like dial indicators and stuff. And so if the tube has got a humpy bump this way, it's going to throw things off. And so I would like to have the tubes straight in the plane of the frame to the extent that I can. And so this is a really quick thing you can do, is just roll the tube, find the high spot, mark it, and now it'll sit in the frame like this. We'll put the miter for the head tube this way and for the bottom bracket this way, and the tube will bow up a little bit toward me when I'm riding the frame. It won't bow out toward one of my knees. And so that's a really quick thing you can do. And after I identify the bow of the tube, I want to figure out, you know, this is a bike-specific tube. I did a video about bike-specific tubing, and I want to know where the butts are. So, like, the wall thickness is thicker on the end. There's a taper. The center section is thinner for weight and for ride feel, and then it's thicker on the end again. And so if we look here on the computer, this is from Nova, where I bought the tube. So this is the tube. Well, that's not the tube page, but that. And then here we have the tube, and this is just the butt profiles. And so off of the tube page, I pulled up that information. And I'm not taking a huge length off of this tube, so it'll be fine, even if I cut all off of one end. But you can imagine if you had a tube that was longer than you need, and you're cutting a little bit off both ends. Let's say you took a heavy cut off one end and a light cut off the other end, and sometimes usually the butts are longer on one end than on the other. If you took a long cut off of the short butted end, now you might be welding in the zone that's not even fully the thickness of the butted section. And so we just want to know where the butts are. We want to mark them out, and then that way we can put our cuts in the most sensible location. And so Nova does a thing where they say the painted end is the short butt end. So there's a little bit of paint residue in here. It's not super clear, but that's the short butt end, and I wrote that on there. Another way that you can do this is you can take something like this, and you can set the tube on here, and you can figure out where does it balance, right? And you see this little dotted line that I put on here? I put that at about the balance point. And then this thicker line, that's actually the middle of the tube by distance. And so if when the middle of the tube is centered, it wants to fall this way, that suggests that this end of the tube is heavier. So this one must have the longer butt, and this one must have the shorter butt. And so it checks out, right? The information checks out. So what I would take with this information is I could look at that chart there that shows me how long each butt is, and I could do a mark. You know, it's this far from the end for this thing. I know, based on those numbers, that I'm not really worried about cutting it too short, but I will take a little bit of a longer cut off the long butt end than off of the short butt end. So for the miter lengths on this, I need to know the distance between the cuts. And I don't have the best setup for main tube mitering, the most sophisticated setup. So the way I'm going to do it is I'm going to measure from the bottom of the head tube, where the tube meets the head tube, that miter, the crotch of that miter, to the deepest point of the bottom bracket miter on this end. So BikeCAD gives me that dimension, and then I'm gonna measure that, and I'll do first the head tube cut, and then I'll do the bottom bracket cut. And the whole time, I'm gonna be using one of these Paragon Machine Works tube blocks, clamped and locked on here, and that'll keep it easy for me to phase the tube the clocking of the tube or the phasing of the tube. With that block on there, I'll be able to drill the holes for the water bottle bosses, and I won't need to reorient things or pick stuff up again because this gives me square edges, and so it's really easy to index on 90, 180, 270 degrees off of my starting location. So first I just need to put the mark where I'm gonna cut my first cut for the head tube, and then I need to know the distance away. So I'm pulling that stuff from BikeCAD, putting some marks on it, and then we'll go to the mill and start chopping. So this is the short butt end. I'm gonna rough cut with a hacksaw to remove a little bit of this material so it goes smoother when I'm actually mitering it. So yeah, it doesn't really matter. There's length to the tube, so I'm just gonna rough cut to this line. All right. Okay, so I can set this up in the milling machine and make a cut on this end, and then I can measure from that to the other end and go from there. So I think that's an easier way for me to go about this than what I was originally thinking. So I use BikeCAD to figure out what the angle is between the head tube and the down tube. So right now the down tube is like upside down of how you would see it on the bike. And the spindle center line represents sort of the axis of the head tube. And we need to put a hole saw on here that's the right diameter, and then we need to make a cut along sort of the axis of where the head tube will be when this is in the frame. I don't know if that's gibberish, but BikeCAD will tell you the angle between the head tube and the down tube, and that I need to actually take that number. I need to say 90 minus that number, and that gives us what we can use here, just because this measures 90 from the level, and on BikeCAD it does 90 from vertical. But anyway, 21.9 is the angle that it's reading in BikeCAD, so we're pretty close here. And so that sets the angle. I also need to get on the tube center line, and also I need to phase the tube. And so here we have, this nice square block here that I can use for phasing. So I can spin this around, and I can use a square here against the machine table. And what's nice is that even though I have a couple adjustments to make, they're all isolated from each other. I don't need to make them, like this one negates the other one or something. So now I have this tube is kind of squared up to the machine. And I should get a shorter Allen wrench. So this, of course, is my Miter Daddy tool that I've done some videos about. And, it's just really good for holding a variety of different tubes, all with the same tool. It's not always the fastest or most sophisticated thing for, if you're making your living building bikes, you probably want something a little bit more robust. But if you're getting started on a budget in a small shop, this thing can hold so many different kinds of shape tubes, different diameters. Really can be a lifesaver to have. I wish I had something like this when I was getting started. And so yeah, now we got the tube phased. We have, this is snugged up and it's at the right angle. And I think I'm actually going to choke up on it a little bit though. So I'm going to loosen these and slide it back some. So this is an edge finder. I've talked about these before. A lot of people know what these are, but it's just a little spring-loaded thing, and you use it to figure out where you are in space on the machine. So there's three different axes. There's an X and a Y and a Z axis, and right now we're trying to get centered up on the tube center line, which is the Y axis. So I flip this thing on and I put this up into the spindle. And so it's wiggling, and as I feed in slowly, it'll touch the edge, and then the friction of it touching will kind of kick it off to the side, and that's when you know that you're just touching it. Now the diameter, the tip of this is 200,000ths of an inch, so if I put this in inch mode, I could say that I am positive 0.1 in the y-axis. And now if I bring it back to 0, that would put me on the edge of the tube, but I don't really want to be on the edge of this tube, I want to be on the center of it. And so I'm going to go until I'm at you know, the radius of the tube in the negative direction. So this is 1.5 inch tube. I had to check because I forgot. So that would put us at negative 750, and Y is going to put us on the center line. And now, even if we change tube diameter, we're still going to be on the center line because it's held in this V, and regardless of the tube diameter, it's going to sit in the same place on the Y-axis here, which is really convenient. So I'm using the hole saw to make a cut on the down tube, and I want it to fit against the head tube. And so basically, I'm looking for a hole saw that cuts at this diameter, right? And this says 1.867, and so I got to find a hole saw that's the closest to that I can get, and I think I have one that's 1 inch and 7/8, which is you know, 1.875, very close. Yeah. So this says 1 inch and 7/8 on it, which is, you know, 1.875. So that's very close to what we want. We'll see if it cuts on, if it gives us the right fit, but we'll start here and try it out. So I'm on the tube center line. I set the angle. I phase the tube this way, and I'm ready to make a cut. I'm up to my mark here. This first cut is not so critical on the length because I'm going to set the other cut according to the first one. My vise is tight. Well, now it is. So, and my table is locked down. That's what these are. So I'll take a cut. So we made the cut, and I'm just gonna grab the head tube and test fit it and see what it looks like. Okay, so this is what it's actually gonna fit up with, so this is a good test. But if I put it on here, you can imagine if it was cutting a smaller diameter than you would like, it would pinch on the outsides, and you'd be able to teeter it back and forth like, you know, like a seesaw or something. And if it was cutting at a larger diameter than it's supposed to, then it wouldn't be pinching there at all, but you would be able to wiggle it this way a lot because it would just be kind of free floating in there. And it's pretty good. You can't wiggle it this way very much, and you can't really tip it the other way. It's pretty good. And so I'm going to call that great. And I'll take it off and deburr it. And before I weld it, I'll get a better look at it. And if it looks like there's a little bit of a gap on one side or the other or whatever, then you know, I can go in there with a hand file and I can just kiss it off a little bit, just touch it. But yeah, it looks pretty good to me. I'm pretty happy with this. Gonna use this triangular scraper just to deburr the inside. I already started. You know, it's looking pretty good. And then 1 inch belt. And I have a whole video about, you know, prepping for weld, you know, how I want to knock back that sharp, thin edge that comes off to a very thin point. I want to blunt that back, and I have a whole YouTube video just about that topic. So, again, I need to make a rough cut. And the whole idea here is that the hole saw, you know, people use them for plumbing to cut a circle. We're using it to cut an arc. We're just cutting the half-round shape on one side. We don't really want the cutter to be cutting on this part of the tube and this part of the tube. This blue line here represents the cut line that we're going to, roughly. This is just a rough mark. But basically, the cutter is going to come in here, and it would be cutting on this side and on this side. And I would prefer to kind of do a rough cut here so that it's mainly just cutting on one side. So that's what I'm doing, is I'm trying to cut it, you know, short enough that it doesn't need to work quite as hard, but, you know, I don't want to risk cutting it too short, and I don't want to spend all day with it, so I'm going to cut it a little bit long, and, yeah. So here I have it just mocked up in the frame fixture. You can't set it in there because the bottom bracket shell and the head tube, it's not short enough to fit yet, right? But this, with the miter we put on, I buy that. This is where BikeCAD told me the number is, and that looks like the crotch of the bottom bracket shell. So I feel like I kind of trust my numbers more or less, and I'll measure this more accurately now and scribe a thin line. Something like a Sharpie mark is good for crude, crass work, but you get into detail stuff. What you'd like to do is maybe make a scribble with the Sharpie and then scribe a line with something sharp, so you have sort of like a thin line quality, and you can come right up to an edge or something. And then we might end up making the cut 2 or 3 times to sneak up on it, since I only bought one of these tubes, which is, famous last words, right? Oh, I just bought one. I'll get it right the first time. So I'm gonna sneak up on it. If you were a serious, frame builder making your living making bike frames, you need to be able to make a bike frame fast. You wouldn't have time for that, but here in the shop, I mainly make tools and stuff, so I'm working with what I got for a process that makes sense for what I'm doing. So, like I said, I'm really not set up ideally for main tube mitering. Ideally, you would have something like the tools from Sputnik or Anvil. They have scaled center-to-center mitering, and they rotate on a rotary table. They're very fast and efficient to use. But, I never built a whole lot of bikes, and now I'm not even building bikes as my main thing. And so I'm not going to invest in that right now. But I do have ways worked out to get the job done. And what I'm doing here is, establishing the length from the one cut to the other one is really important, and it's kind of tricky to do. So what I've done here is, this is part of my tube bender, but importantly, it has a 1.5 inch radius here. And so what a half round tube block, just like these Paragon ones, will do is when you set it on the tube, you can't really wiggle it this way, and so basically it gives you a straight edge that you can transfer a line from one side to the other, and it projects a certain point. Like if you put a dot here on the side of the tube, you can line this up, and now even with this tube block on here, I can measure the distance between the edge of the tube block and the edge, like where that dot is, because it projects that straight up, if that makes sense. So here, I put this so that it's just touching. I'm trying to measure from the edge of the miter in the bottom center. I'm trying to, and if you look, the inside of the tube and the outside of the tube, well, the inside of the tube is further over. So I'm going to line it up with the outside of the tube, and then I'm going to just hold it there. Just a little bit slippery because it's anodized. And then I'm going to put my ruler, and this is a decent ruler. I'm going to put the end of that up against there, and I'm going to measure from the end of this block to the end of this side of the Paragon block. And so I got, when I measured this before, what did I get? I got like 343 or 344. Yeah, 344 is what I said I had. So, I'm trying to get it as close as I can. This works, but it's smart to kind of sneak up on your number. If you overshoot it by 2 or 3 millimeters, you don't want to weld a gap that big by any means. You could tweak your frame fixture in just a little bit shorter, and your bike would basically ride the same way. But I would like to not have to do that. So I can measure this section of it here, and then I can subtract that from the total distance, and what I'm left with is this section of the tube, and then I can measure that section, and I can use this to transfer my line from the top of the tube to the side of the tube. It's a whole frickin' production, but it's what I got, and it does seem to work. It's just really slow, and you need to be careful. So, if you take your work seriously, or you do it very often, or you like the satisfaction of nice tools, just like, buy the proper tools. But if you don't, if that's not you, this method might help you. So I subtracted from the total length, I subtracted this distance, and what I'm left with is 361. And so I marked it with a Sharpie, and I'm right on 361. And now I take my sharp, pokey spoke, and I'm just going to scribe it. And now that's a nice thin line to work up to. That you can really, you can see that pretty clearly. And so that's going to help me as I'm setting up the milling machine to make this cut. And so let's go to the mill. All right, so the miter daddy goes back in the Kurt vise here, and it's got this pin so that I can set the angle more easily. So I got to line that up with the socket head cap screw. So the things I need to do, I should already be on the tube center line. I need to change the hole saw. That's easy to forget, but the head tube has a different diameter than the bottom bracket shell. So I got to change this before I make my cut. I also need to get the tube phased. I need to set the length, and I need to set the angle. So I'm gonna work in on it little by little. So I'll set the angle right now. It's a 90-degree cut, so I want this to sit as level to the machine as I can. But I feel like, from my experience with this sort of thing, getting within half a degree or less is usually plenty good. The hole saws don't make perfect cuts as it is, and so really what you want to do is you want to get the best cut you can, and then you want to check that in the fixture before you weld it. You just want a nice tight fit, and if you have an asymmetrical gap, it's going to have a tendency to want to pull your frame out of alignment. So you want to have the tight fit, and I'm going for that, but you know, I don't know if it needs to be perfect. So that there is about as close as I can get. The table of the machine is pretty well level, so I know that when this reads 0, that's pretty damn close. I mean, as far as this thing is concerned. Now I want to set the phase of the tube. So again, having this Paragon block on here the whole time really makes it easy to do that. I'm going to loosen this up again because, you know, you set the angle and you lock it, and then you set the phase and you lock it. And while I'm doing the phase here, I also want to keep in mind that you always want to be choked up as tight as you can on the tube. So the edge of the hole saw only needs to come as far as that thin line I scribed. So I can choke it up further into the tool, and I'm going to do that. I'm going to take advantage of that. I'll make the cut more rigid. So I don't want to cut into my nice tool, but that's safe there, and that'll cut a little bit nicer. And now I just kind of spin the block against my square, and I tighten it up here. You always just got to be mindful to tighten up the sides kind of equally so that the top pin here is square. So this is obvious, but you know, I know that this bottom bracket shell is 1 3/4 diameter. I know that. It's like, I know that. There's no question about that because I've been thinking about these numbers. But you know, it's a really easy check is just take the hole saw you're about to use and just kind of do a little visual check, an idiot check. Yep, that seems like the right diameter to me. You know, it's really easy to screw some of these things up, and I learned that one the hard way at some point. I don't remember, but you know, it's really easy to just kind of hold it up and visually check. Yep, that makes sense. So these cuts on either end of the tube, there's not just a distance, and it's not just that it needs to be clocked at some interval of 90, some factor of 90, but we need to do it the right way. So here is this head tube cut, and it's going in this direction, and because of this angle here, I know that this is the top side of the down tube, and this is the bottom side of the down tube. And so that really matters that the bottom bracket cut comes in this direction and not like this, right? So you need to be paying attention. I think I screwed that up at some point in the past. But not only that, as I described in the other videos, I want this cut to be, I want the bottom edge of the down tube to be nearly tangent to the outside diameter of the bottom bracket shell to create more room for welding. And so if I bias this cutter in the wrong direction, I'm making all sorts of headaches for myself. So I want to get that in the right direction. So I really need to be paying attention here. This is the bottom of the tube, and so I want this cutter to be nearly tangent to it, and I'm going to use a square for that. Ideally, you would actually take, you know, a cut that was measured off of the distance, you know, one side or the other. But in this case, I'm just gonna eyeball it, and I think that'll work for me. And so yeah, this here is just about what I want. I can see that, and so the other thing is lining up with this scribed mark here. It's really hard to see on camera, I imagine, because it's dark here, but you know, I'm just bringing in the cutter, and I just got to make it line up. So yeah, you can't really see that very well, but I can see it a little bit better, and line it up to the best of my ability. These hole saws don't always cut true, you know, they cut a little bit out around, and so it should still make a round shape. What it means is that the tooth that's the furthest outside of the spindle center line is the one that's, you know, maybe doing the most work. But what that does mean is when you're lining up to a thin line, you wanna spin it around a little bit to check for that and see which one is the furthest out. You know, where is this the furthest off of the center line? And so I'm gonna back it off a little bit. Something like that. I don't know. I want to start a little bit long, test it, bring it back, do it, you know, a couple cuts. It's going to be slow, but I don't want to blow this right away. So I think I'm ready to make my cut. Table is locked. Vise, you got to do this check every time. Vise is tight. The correct cutter is in here. The tube is phased. This is tight. This is you know, square to the machine. We're ready to make our cut. We're nearly tangent. We're at the line. Because I'm in low range, I flip it into what's called reverse, but that's the forward direction. So I can see now that with my hacksaw, when I rough cut this to length, I should have left it a little bit longer. So there's not really any harm done here. It'll work out fine. But you can see that the edge here, that's what I cut with the hacksaw. So I'm gonna blunt this back anyway when I prep it for welding. And so it's maybe, you know, 4 or 5 millimeters longer than it needed to be. But I should have left a wider margin to be safe, so that I didn't risk cutting it too short. So, you know, it's just a good lesson, and always, you know, really checking your numbers and that sort of thing. So we're doing a test fit. I love these moments when something like a boring old tube turns into like part of the structure. And so I can actually just keep the Miter Daddy clamped on how it was, and this Paragon block clamped on how it was. And what we do is we use this notch here. I didn't even deburr this yet. I just kind of set this on according to the guides, the little scribe marks that I put on, get it centered, and then I drop the tube in here. And how are we looking, you know? So is it centered up? It's a little bit, okay, so that's about centered up there. And my miter down here is looking pretty decent. And as you would expect, it is sitting high on the head tube because I cut it long. And so as I trim that down a little bit, this will come lower. And so I think I'm going to take a measurement from the bottom of the tube here to the top of this like head tube puck, and we'll see where we're at there. And then I'll just take another successive little cut again. It looks like there's almost more of a gap at the bottom than there is at the top here, which tells me that my angle is maybe a little bit off here, or possibly it's suggesting that something about this setup on the frame fixture and the geometry of this is possibly off. And the reason I would say that is that as I cut this tube shorter, it's gonna drop down, and this gap is only gonna get wider, and it's gonna sit tighter on the top and looser on the bottom. So I can already see it's a little bit looser on the bottom. That's not a big deal. As I trim it in, I'm just gonna, you know, keep an eye on that, and then if I gotta touch it up with a hand file to get a nice tight fit, that's what I'll do. Again, you know, this is more of the way that I have done things with a small shop on a limited budget, and it's not how you would want to do it if you were building bikes to you know, pay the bills or something. So I'm just gonna take another cut. I put it back in the machine. I set it to 90 again, or, you know, level with the machine, perpendicular to the spindle. And because of that pin, it sits back in the machine just about exactly the same spot. That pin has a pretty good fit. It's a 3/8 diameter pin in a cap screw that's made for a 3/8 hex tool. So it fits in there nice, and it's pretty repeatable on location. And so here I had this zeroed out, or, you know, that's basically zero. So I'm just gonna move the table over 1 whole millimeter. We'll see, you know. Close enough. And so that'll cut a little bit shorter, and then we'll test it and check again. So I made another little baby cut. You know, this is a slow process, but another subtle cut on the end there. And what that does is it does a couple things. It makes the tube shorter, and it does move in that direction, but then it can drop further on the head tube. And so what I had done actually was to scribe a line here. I don't know if you can see it very well, but I scribed a line for where the bottom of the down tube should sit, which is 12 millimeters above the bottom of the head tube itself. And so I can sneak in here with a ruler You know, right now it's at like 17 or 18, and it should be close to 12. Is that critical to the way the bike rides or anything? Not really, but I want it to be pretty close. I designed it around that. So I'm going to try and hit that. And as predicted, you know, the gap at the bottom is growing a little bit, and it's sitting tight at the top with a little bit of a gap at the bottom. So, you know, I don't really want that. When I go to weld it, I want it to be tight all the way around, especially because the top is the easier part to weld. The bottom, you've got this thick and heavy tube, and then you have a relatively thinner tube, and you're trying to get in there at a tight angle, and it's going to want to burn through this tube more easily. And so, you know, having a tight fit up is like one of your best defenses against blowing a keyhole in this thing as you're trying to weld it. So, maybe just touch that up with a hand file since the shape is already there and I've moved the tube block. But yeah, I mean, like another little millimeter cut or something, and we'll be getting in closer. So getting old school here, I'm just gonna use the hand file to kind of just dress this a little bit, take a little bit off of this top edge, and carry on with the cuts down there. There's all different ways you can do this, but I know this will work, and so yeah. Just kind of hold the file at the angle of the head tube, and then just, you know, kind of putting pressure on it so it's only cutting on the back side. And, you know, anything behind these sort of ears, if I just do a little bit kind of evenly, it'll sit a little bit nicer in there. These damn copper jaws. I always complain about them, but I never take any time to fix them, and they just want to fall on the floor all day. It's so frustrating. Cool. I'm going to take another millimeter off of the length of this. I was also noticing that with the tube in there and centered up on the bottom bracket shell, it was a little bit tight on this side and a little bit loose on this side. So that suggests that it actually isn't totally square to the spindle of the machine, or that, you know, the way that it cuts, there's some deflection or so, whatever. But what I can easily do is just lift this side up a little bit and it pivots. And so I did that just like a half a degree. We'll see how it fits in the fixture this time. So this fits in decent now. If I set it on the bottom bracket shell, I tip it down, I check that it's centered on the bottom bracket shell, and what we have is it's sitting a little bit high up here, and it's a little bit more of a gap at the bottom than at the top. And so at this point, I feel like this miter for the bottom bracket is as good as it needs to be off of the machine. I'm gonna get rid of this tool from here, and then I'm gonna bring it in closer with the hand file at the bench there, and I'm just gonna, you know, touch it up, check it, find the tight spot. You just kind of look around the circumference of the miter and you see where does it look like it's tight, where does it look like there's a gap, and then you remove material until it, you know, kind of goes in the direction that you want. And when I get these, then I can drill the water bottle holes, and I can also do the real tricky work, which is annoying. I'll probably just do it completely by hand, which is to be able to fit the seat tube in here, I need to make clearance. I need to remove a whole arc out of this, and that's gonna suck, but it's gotta happen. Mountain bikes are particularly hard to build, I think. Out of all the different kinds of bikes, you got some cargo bikes and things that are complicated, certainly. When you're talking about like road bikes and track bikes and I don't know, cyclocross bikes and stuff, I feel like a lot of other bikes tend to be easier, and mountain bikes get more and more complicated because you have tighter clearances of things, like, you know, between the chainring and the tire and stuff gets to be, it's kind of a tight spot on a lot of bikes. If you want to bend the seat tube, that gets complicated. You start working about like the fork crown clearance. There's just like a lot more going on a mountain bike. And here, like, I'm biasing the tubes so they're almost tangential to the bottom bracket shell, and that complicates mitering. And so every little thing that you do like that. Just makes stuff a little bit more complicated and kind of slows you down some. And that's fine, but they just figured I'd point that out, that I think mountain bikes are a particularly difficult one, especially for beginners. And really the rear end tubes, the seat stays and the chain stays, getting those bends where you want them. If you buy off-the-shelf tubing, you're not going to have much control over that process. Would really make it difficult to make a short chainstay, short rear end bike. And if you do have tube benders, it's still kind of tricky to know exactly where to put the bends and all that stuff. So mountain bikes are just hard, and I want to point that out. So in order to make this actually fit into the frame with the seat tube in here, of course, we need to notch this out so that these can both occupy this same space at the same time. And you know, ideally you would just set this up and you use BikeCAD or something to derive your number and you'd make a cut. This here section of the tube is basically straight, has a known diameter. You could figure out the angle. So you should be able to make that cut with a hole saw so that it has a nice tight fit up. But let's say you get it wrong and there's a big gap there that's really hard to fill that with weld and it's not ideal. And if it's too tight, then you're gonna have to file it back with a hand file. So I think I'll probably just do the whole thing with a hand file. It shouldn't take that long. It's just walking back and forth to the bench vise a couple times to just kind of, you know, work that in. And it's tricky because I kind of eyeballed these to be nearly tangential to the tube and not exactly measurably. And so that just presents issues then with, you have a kind of a small margin here as these come in together at a shallow angle. If you're off just a little bit, you're going to have a pretty heavy gap there, and I don't want that. So I think I'm just going to walk it in with a hand file and sneak up on it. But that'll be the hardest part of this tube, and we'll do that in the next video where I also drill holes for the water bottle cage, and then the top tube should be pretty easy because it's just two miters, and yeah, that should be pretty simple compared to this one and even the seat tube. And then we'll carry on with even more. Thanks for watching. We'll see you on the next one.